Hello everyone. My name is Tarmo Kellomäki and I represent a company called Huld Oy, where I work as a director of digital security and functional safety. My presentation goes under a rather new topic of cyber safety, in which I discuss about the integration of safety and security in industrial cyber physical systems. But first, a couple of words about the Huld company. Huld is a 30 million euro and Finnish-based company, which currently employs over 450 people in various locations in Finland and Czech Republic. We are strong where the physical and digital worlds meet. Our vision is to be the leading design house in Europe, and we address the challenges of societies and organizations with the help of new technology innovations in order to create an intelligent world. We like to group our services in 4 different categories, which are digital services and software, product design and development, embedded solutions, and the safety and security, in which I'm responsible in the company. We operate in various different businesses, and our customer base includes variety of industrial customers, all the way from healthcare to space domain. But then, let me draw a little landscape for you. I argue that traditional industrial system environments are functionally safe, but due to a poorly managed digitalization efforts, they can become both digitally insecure and functionally unsafe. But let me start by giving you a couple of definitions and some characteristics of the cyber physical systems. So what is the cyber physical system? The concept of cyber physical system was coined about 10 years ago or so, when the researchers tried to come up with a good term that this would describe the essence of the new generation of industrial systems. A definition that I use, it's from the Springer.com. It means that the cyber physical system consists of collaborating computational entities which are intensively in connection with the surrounding physical world. And all the ongoing processes, for instance, industrial physical process. And all the capabilities and services, the data access, the data processing, they are available through the internet. And that's maybe the most important thing when we talk about the cyber physical systems. Good examples of these modern cyber physical systems I have listed here. They include traffic control systems, smart power grids, autonomous automobile systems, medical devices, industrial control systems, and so on. And all these system types have common characteristics of having system components from the operational technology, such as PLC components, SCADA software, and so on. And many times these technologies are rather legacy in their nature. But nowadays, these cyber physical systems also include a lot of embedded software and hardware, and the characteristics also include the need for real-time operation, and they are more and more wired to network and also having the wireless network capabilities. There are a couple of main requirements that relate to cyber physical systems when we think about the use of these systems. Usually there is a high demand of safety, whether it's the safety of the humans working around the systems, or whether it's the environmental safety. If you talk about, for instance, chemical industrial processes, for instance. But also these systems need to be reliable, fault tolerant, to be able to achieve a robust control of the functionality that they are operating. As we all know, the industrial systems are facing a tremendous change in the forms of digitalization. This change is discussed under a concepts of Industrial 4.0 or 5.0, which means that the old closed industrial environments are equipped with connectivity to internet in order to gain business data from the industrial processes and in order to develop new capabilities for the operation, for instance, in a factory. One good example of that is a predictive maintenance. The huge facilitator of this development has been, of course, the different IoT solutions, which are explosively introduced in the industry. And this is a well-known picture of the prediction of the IoT solutions that are introduced in the industry. But then there are lots of different challenges that this digital industrial revolution is addressing. And the challenges, first and foremost, relates to the protection of the cyber-physical systems. The typical industrial environments have been designed for decades for operating in closed environments. So therefore, there hasn't been really a huge need for security requirements for the components. On the right side, you can see a couple of examples of vulnerable operational technology components that are used in many industrial automation control systems. And as you can see, there are many different cyber-related vulnerabilities that needs to be addressed in the future. What is also typical to these industrial environments that they are many times very hard to update the systems, because the operation, for instance, in the factory, it needs to be available all the time. It's very hard to do the update mechanism operations for that. But also, since these systems are developed with a high demand of functional safety, the safety configuration cannot be hampered by introducing different updates. So it's many times a financial issue that can we really update the systems. Other things are of course that these systems, typical cybersecurity controls, firewalls, antiviruses, they are much harder to implement the OT systems. But of course, the newest generation of the OT technology has, of course, the capability of having these elements in place. One thing which is I think is very crucial, and I will be addressing this issue later of my presentation, is that these industrial environments, they have a long cultural, long history for functional safety. And typically, the safety people and security people are working in different departments of the organization. So there is a huge gap of getting these people together and trying to solve these different challenges that relates to, for instance, the connectivity that I have in the previous bullet. So since these people are working in different environments, you cannot address the security issues and safety issues in a common manner. And of course, the IoT that I mentioned earlier, there's a need for short time to market. And I would argue that many industrial systems are not for digital security. Not digital introductions, especially from the security point of view. This digital revolution has, of course, ended up many different unfortunate examples where these cyber-physical systems are attacked. The most notable ones are Stuxnet, Indestroyer at Triton, but there are lots of other good examples where a whole facility of industrial facility has been compromised by using cyber attack methodologies. Which is notable in these examples that no internet connectivity was used in these particular cases. So think about the potential what this connectivity will bring to cyber attackers in the future as they can operate via internet to these environments. So as a summary for the landscaping, I would say that the modern cyber-physical systems are changing the industrial environments a lot. The biggest changes are, of course, the convergence of IT technology and OT technology. Another thing is that it is predicted that almost every industrial system will be connected to internet by using 5G, for instance. This development causes many new challenges to traditional closed industrial environments, and they become more open for cybersecurity attacks. And that influences that cybersecurity issues become also functional safety issues. So I would state that, or my question is that, do we need a new approach in cyber-physical system protection? And my answer is yes. One solution for this protection of cyber-physical system is a cyber safety approach that we see at Hult as a next big step in the protection of cyber-physical systems. Cyber safety is about integrating the development of functional safety and cybersecurity in a cyber-physical system. This animation that I have here is an illustration of how cyber safety protection should be handled in this industrial environment. As you can see, this is a picture of some industrial automation system, which is operating a robotic arm in some kind of, it can be from an automotive factory. This robotic arm is controlled by process automation control software and hardware. And traditionally in functional safety, for decades, the functional safety engineers have been defining the safety functions for this physical process of the systems. It means that they define the security, the safety level for the system. You identify the hazards and the requirements for the safety functionalities, and you also implement and verify them in a similar way that you do in cybersecurity. So this makes sure that the process itself is safe, and it is and has been for decades, as I've been saying for many times. But as this robotic arm now is connected to internet, there are lots of new attack surfaces that are influencing this system. And whether it's a denial of service attack, whether it's a failure in software or hardware, these cybersecurity issues become also a safety issues. Because let's say you can do a denial of service to the safety critical parts of these systems. And I think the ultimate bad example is a nuclear plant, where you can use the cyber attacks to damage the physical process of the nuclear reaction. Along with defining the safety elements to that system, you need to define also the security levels. And this is a typical process where you define the security level for the system, you identify threats, the requirements, and ultimately do the implementation so that you can make sure that the cyber defense of the systems is in place also. The cyber safety approach is that you assess safety and security risks jointly in a manner that you can really look into the risks, cause and consequence relationships in a mutual way. The cyber safety approach that we are using at Huld is that we use the commonalities of security and safety engineering methods, whether it's risk management, threat or hazard analysis, or the architecture design or mitigating controls. And by doing this, we can make sure that the industrial system risks are really assessed holistically, and we can bring together the functional safety experts and the security experts, and we can really make sure that the systems are in good shape when we think about the protection of the system. These functional safety engineering methods are highly standardized in a similar way as in the security disciple. And what we are doing at Huld, we are using the most typical functional safety standards and cybersecurity standards in a joint way. So ultimately, we can come up, for instance, this deliverable where we do a safety plan for the safety critical system, which is in this case it's done by under IEC 61508 standard, and having only this contents on the right side, this is a typical contents that you develop in a functional safety project. But with our cyber safety plan, you can include also the cyber security related elements to the development of safety critical systems, and you really can have a holistic approach and poster in your industrial system. So thank you very much for your interest. Here you can see my contact information. I'm happy to answer your questions if you have one.